The most famous member of the Afarensis species is this almost complete skeleton, a female individual called Lucy.
Well, scientifically, Lucy didn't tell us anything that we didn't already know. However, her skeleton is 60 to 70% complete, and it gives us a much more realistic vision to present to the public. Everyone has heard about Lucy, and everyone knows about this early form of human. So in terms of public relations and human evolution, Lucy is a great centerpiece.
Lucy is of importance principally as an icon. When Lucy was discovered, the human fossil record was much smaller than it is now. And the species to which Lucy belongs has turned out to be a very, very important stage in the evolution of the human family. And Lucy was among the first individuals of this species to be found.
Fossils of this species have also been recovered from Omo in Ethiopia and Laetoli, Tanzania, where the oldest known human footprints were discovered. It was a fortunate accident that occurred nearly 4 million years ago. Mary Leakey discovered a trail of footprints at Laetoli in 1978. It develops that a pair, possibly 3, Australopithecus afarensis walked through wet volcanic ash produced by nearby Mount Sataman in Tanzania. The wet ash becomes like concrete when it dries, and it left very distinct and well-preserved footprints of humans that lived there nearly 4 million years ago. It's understood that it was raining at the time the footprints were laid, because researchers even found imprints of raindrops in the sediment. The footprints are proof of bipedality. The indications that these footprints are from an upright being are a well-developed arch to the foot and a big toe that is in line with the other digits, unlike other primates, whose big toe is opposable, like a thumb. Also, the animal had a very defined heel strike, similar to modern man. The footprints reveal quite a lot. Their approximate height and weight, for example. Another bit of proof of upright walking is a knee joint found by Donald Johanson in 1973. The knee joint of a primate is markedly different from that of a human. Even an upper arm bone can show evidence of bipedality.
This is the bottom of the upper arm bone. And in a quadruped, there would be a large bar of bone along this edge here to prevent the elbow from dislocating during quadrupedal locomotion. We know this is a bipedal arm because that ridge of bone is missing there. No weight was transmitted through this elbow joint. This particular specimen is about 2.5 million years old. So this is a very clear indicator that bipedality is quite old in the hominid lineage.
Of all the characteristics that separate us from any other species on the Earth, walking upright is one of the greatest achievements.
In general, most paleoanthropologists today would point to upright bipedalism as being the key feature that set early humans apart from their closest relatives and started them on this trajectory to what we are today.
There were bipedal dinosaurs, but they used their tails as balance. And birds have their wings as an additional form of locomotion. We're the only animal who has committed entirely to bipedality. It's also our oldest trait. The very earliest hominids are in fact defined by their bipedality.
But why do we walk upright? A variety of reasons have been suggested.
One idea long was that, in fact Darwin's idea, that bipedality evolved because it freed the hands for tool use or for weapons use. But we now know that bipedality occurred at least 2 million years before the first stone tools appear. So there's no relationship initially between bipedality and tool use.
Some would say hands were also needed for gathering and carrying